4 over 3 x to the negative 1/3 minus 5 over 3 x to the 2/3. I use this form to find the second derivative because it's easier to manage, and then we can clean up later on. So we have 4 over 3 times negative 1 over 3, which is negative 4 over 9 x to the negative 1 over 3 minus 1 to be negative 4 over 3. And the next term, we get negative 10 over 9 times x to the negative 1 over 3. Okay, the common factor as negative side of 2 over 9. Just clean up. And in parentheses here, we have 2 over x to the 4 over 3. Change negative power to positive power. Plus, and this is factor the 2 out, so this can be 5 over x to the 1 over 3. Okay, and then we can manage this. I'm gonna copy it again. Mm, Oops, nice. All right, to manage this, we have negative 2 over 9, and then the common denominator of these two fractions is x to the power 4 over 3. Okay, that tells me I'm gonna make the second factor to have the same denominator. So I'm gonna multiply both by x and x because x as x to the first power. 1 plus 1 over 3 is 4 over 3. So that will give me the same power as the first fraction. Now the numerator becomes 2 plus 5x. Okay, 2 plus 5x. And then from f double prime in this fraction form, it's going to help me find the possible inflection point. Okay, possible inflection point, that means from the case that f prime equals 0 or f double prime undefined. Okay, in this fraction form, as you see, the negative 2 over 3, 2 over 9 is just a coefficient, no x involved, so we don't have to worry about that. So take the numerator for the case that f double prime equals 0. We have x equals negative 2 over 5. Okay, negative 2 over 5 or negative 0.4. And then for the undefined, going to be the case that the denominator is 0. Denominator is 0 or x equals 0. So two possible critical points. Okay, from two possible critical points, now we're going to use the real number line again to identify the interval of increase decrease. Okay, so f double prime 0, we get x equals negative 2 over 5. F double prime undefined, we get x equals 0. So real number line for the f double prime. And our f double prime is from the full form is negative 2 over 9 times times the 2 plus 5x divided by x to the 4/3. Okay, the two possible inflection points negative 2 over 5 and 0, and analyze the same way. For the number negative 2 over 9, for the factor 2 plus 5x, for the factor x to the power 4 over 3. Number negative 2 over 9, any number gonna be negative sign for the factor negative 2 over 9. Okay, that's a negative sign, negative number. For the 2 plus 5x, refer to this reference point. The right hand side, the number greater than negative 2 over 5, gonna make it positive. So plus sign, plus sign. Less than negative 2 over 5, gonna be negative sign. And for the x to the power 4/3, so this is the cube root of x to the 4th. The power 4 gonna make the number here always positive. It doesn't matter what x gonna be. You raise to the fourth power, the sign will be positive, and take the cube root, it will remain positive. Okay, remain positive. So the when you put this together as negative from negative 2 over 9, positive from the factor 2 plus 5x divided by positive sign from x to the 4 thirds. So it's gonna be negative for the first interval or the one on the right end, and then the next one gonna be negative. Okay, and then another one gonna be positive. So from what we have here, positive side, I'm happy. So this is the concave up interval. Negative side, not happy. This is concave down. And this is another negative side, concave down. So then from this, the interval of concave up gonna be negative infinity, negative 2 over 5. And the interval of concave down or the sign negative gonna be two of them. You cannot combine them because 0 is kind of the resting point. Gonna be negative 2 over 5, 0. Stop at 0 and start again right after 0, 0 to infinity. Okay, so you don't combine the two concave down interval there because 0 is the breaking point. And then next, you can identify the inflection point. Inflection point occur when the sign switch from one to another. So only x equals negative 2 over 5 is the inflection point. Inflection point at x equals negative 2 over 5 because the sign change from plus to minus, from minus sign to minus sign. So it doesn't tell you that is the inflection point. So this is the the um, the use of the second derivative. And for the second derivative test, that is another kind of, again, that's the add-on problem. You have to refer to the critical numbers. The critical numbers that we found earlier, let me see, the critical numbers gonna be 0, let me see, 0 and 4 over 5, okay? Based on the critical number, 0 and 4 over 5. Where is 0? 0 is right here. Where is 4 over 5? 4 over 5 is greater than 0. Okay, so 4 over 5 in the concave down interval. So gonna be the local local max. Okay, local max. And the 0 here, 0 is in here. So the second derivative test cannot be used to identify local max, local min. So this is another thing, kind of the sensitive part of the use of the second derivative test. So for the 0, the test is inconclusive or it cannot be used. This is the second derivative test. Okay, but the first derivative test can be used because the sign change from increasing to decreasing. All right, from these pieces, now from the graph as a summary. So the graph of x to the 2/3 times 2 minus x, as you see the critical point at 0, 0, and over here is 4 over 5, as x equals 4 over 5. That's the local minimum, and this one is the local maximum. Okay, and the graph decreasing, so right here decreasing, over here it also decreasing, but the portion between 0 and 4 or 5, this part, the graph is increasing. Concave up, concave down. Since the point of inflection is at 4 over 5, no, not 4 over 5, at 0, the concave, uh, sorry, is negative 0.4. At what we see here, negative 2 over 5, which is negative 0.4. Concave up to concave down. So concave up to concave down. So that is point of inflection. from concave up to concave down. And then after that, it's concave down, another concave down, because as you go along the curve, your tangent line is above the curve. All right. So this is the full analysis of the graph that is not polynomial.